All right, so today we're going to talk about relations and functions, and there's about one new thing that you probably haven't heard before called a one-to-one function, and we're going to explain what that is in just a second. All right, for today, we're not really going to worry about what an onto function is, and we're not going to worry about what a both one-to-one and onto function is. So we're going to just focus on the one-to-one function part of it. Okay, so one-to-one function is just one element in the x values is going to pair to exactly one element in the range. All right, so we're going to just give you some examples, so hopefully this will make more sense. All right, so on the first four exercise, we're just going to talk about what the domain and range is. So remember, we already done this before. If the function is given to you as a set of points on a graph like this, then your domain is going to be just all the x values. All right, so all the x values. So I'm going to put all of these x values into here. So we have 0 0.5, comma, 0 0.4, comma, 3.1, comma, and 0 0.4. All right. Now for the range, we're going to list all the y values. Again, I'm only going to do this if I have a set of points, right? If you remember, this is called a discrete function or relation at this point. And we're going to put a 3 here, a 2, a 1, and a 0. Now, like we talked about in the past, if the x repeats, which in this case it does, they're repeating right there, then this is not a function. And if it's not a function, then we don't really have to worry about this is whether this is a one-to-one function or not. So we're done with that one. All right, so let's go ahead and go on to the next one. Now, in the next one, again, let's start off by doing the domain and range. You've already done this before, so I'm going to go through this pretty quickly. Remember, the domain, if I give you a set of points, is you're just going to list all the x values. And for the range, you're just going to list all the y values. Now, this one right here, this is going to be a function, all right, because the x's do not repeat. So this is definitely a function. But then the question is this a one-to-one function? And that's actually very easy to determine. To figure out if this is a one-to-one function, then in that case, the y's cannot repeat. If the y's are being repeated, then this is not a one-to-one function. All right, so since the y's repeat, it is a function, but it's not going to be a one-to-one function. All right, so moving on to the next one, number 3. All right, same thing. We're going to start off by writing the domain and range. In the same exact manner I told you earlier, right? We're going to list all the x values. And then we're going to list all the y values. And then now notice that this is going to be a function because none of the x's are repeating, right? So all the x's do not repeat. Now all the y's don't repeat either. So this is actually going to be a function, but it's also going to be a one-to-one function. All right, so essentially what you need to know is a one-to-one function, only one x can go to one y. Okay, so moving on. I'm not going to do example 4. We're going to leave that blank. I'm sure you can figure that one out on your own if you want to. All right, so let's go to the back of this, the back of your notes. So now it should be on this part right here. Now we're going to go over some stuff that you should already know from the last 2 units that we have covered. All right. Well, let's talk about this one, right? First, our job is to graph. And if you remember this from the last unit, y is equal to 3 is a horizontal line across y is equal to 3. Now, if that doesn't make sense to the fact that this is y, remember that every y coordinate on this line is 3. So this is why we call this a y is equal to 3 line. So now we're going to have to talk about the domain and the range of this. So on the domain, let's talk about, I'm going to put domain down here. Right, because this is not a set of points. In this case, then I do have to write it either in interval notation or with inequalities. Okay, so that implies that it's going to be continuous. So the domain is going to be all real numbers. Remember, because from the left to the right, it's covering everything. From negative infinity to positive infinity, that's all real numbers. The range is going to be y is equal to 3, right? It's begins in this line, it ends in this line. All right, so that's going to be the range. Now, then the question then becomes, remember, we're not going to do onto or any of this stuff. We're just trying to figure out if it is a function, is this a one-to-one function? So this is actually very easy to tell. Now, is this a function? Well, this is definitely going to be a function because it passes the vertical line test. You remember that? The vertical line test says that if I put a line anywhere on here, and if I touch more than 2 points on this curve, or in this line in this case, then it's not a function. So this one's definitely going to pass that test. So this is definitely a function. Now, the question is this going to be a one-to-one function? Now, for the one-to-one function, once you realize that this is a function, then this must pass what's called the horizontal line test. All right, so this one's actually not going to be a one-to-one function. All right, because if I draw a horizontal line, am I going to touch more than 1 point? And the answer is yes, I will, because if I put a horizontal line right on top of that, I'm going to be touching multiple points. Okay, so again, this is not going to be a one-to-one function. Now let's do number 2. All right, number 2, remember, we're supposed to graph this without a calculator. You should be comfortable with that by now. If you remember this from the last unit, this number right here is going to mean down 1. And this is parent function y is equal to x squared. All right, so y is equal to x squared. I'm going to put the key points that by now you should be comfortable with. But remember the x's, I'm just picking those at random, but I know those will work on any graph. And then I'm just going to square. Now, why am I squaring? Because this square, right? So -2 squared is 4, -1 squared is 1, and so on and so on. So don't forget where I get those points. So this lesson is never going to go away. So since I'm starting at down 1, this is my fake origin. Okay, so that point is right here, 0, 0 is not being stretched or anything. So this is 0, 0. Remember, the next point should be 1, 1. So from here, if this is my origin, my fake origin now, I'm going to consider that point 0, 0. So 1, 1 is right here. And then finally 2, 4. From here, it would be 2 and then out 4. 1, 2, 3, 4. All right, similarly, if you go the other way, you can do that the other side just like it. If this is 0, 0, -1, +1 would be this point. And then -2, +4 is also this point. Notice that this quadratics are symmetric, so the right side and the left side are going to look the same if you just split this in half. Okay, so that's what it looks like. Now let's talk about the domain. Domain is going to be all real numbers because it covers everything left and right. The range is going to be x is greater than or equal to -1. Excuse me, I meant to say y is greater than or equal to -1. So then after that, I need to figure out whether this is a function. Well, it turns out this is a function, right? Because it passes the vertical line test, but this must also pass the horizontal line test. So here's what that means, right? This is a little bit easier example for me to show you. If I draw a horizontal line anywhere, do I touch more than 1 point? And if it does, then it's not a one-to-one. All right, so again, this is not going to be a one-to-one function. Just similarly on this one, if I put a horizontal line here, that's not going to pass. That's not going to pass, okay? So for it to be a one-to-one function, it must pass both the vertical and the horizontal line test. All right, let's move on to number 3. Now, number 3, you can graph it many ways, but let's graph it the way that you used to from Algebra 1. Remember, this is the y-intercept, and this is the slope. Okay, so we're going to start at 2, which is right here. My slope is 3. Now remember, the slope, if you remember from Algebra 1, is rise over 1. So I'm going to go up 3 and to the right 1. Up 3 and to the right 1 would be right here, which is off my graph. That's okay, I guess. But I can also go down 3 and to the left. All right, so and then down 3 and to the left. So we have this line, okay? Now remember, the positive always looks like this, right? Positive slope, so don't forget about that. All right, let's talk about domain and range. Now for this one, the domain and the range are both all real numbers, which remember, if you're writing this in interval notation, that would mean from -infinity, you don't have to write both. So both of these domain and range should be from negative infinity to positive infinity. Remember, that's what all real numbers means. All right. Now, is this going to be a function? Yes, it passes a vertical line test, right? It doesn't matter where I put a line on here. It only touches one point on this curve, or on this line in this case. Now, does it pass a horizontal line test? If I put a horizontal line anywhere on here, it's also only going to touch one point. So this is actually a one-to-one function. Remember, a one-to-one function must pass both the vertical line test and the horizontal line test. All right, so let's go ahead and move on to finding each value. Now to this, you should be familiar. Remember, if you have f of 12, and this is function f, all I'm doing is plugging in 12. So f of 12, I'm going to plug in a 12 for every x that I see. Now, I would recommend writing a parentheses because that sort of helps me with my order of operations. So now I know, for example, that I'm supposed to multiply negative 2 and 12, right? So if you do all the math correctly, this should be negative 20. I'm going to go ahead and trust that you can do number 5. Let's go to number 6, which is a little bit different. F of 2b. So in essence, what we're doing doesn't change too much. We're still going to replace the x in this function f of x. We're going to change this x with a 2b. We're going to replace that. Okay? And then now we're going to do the same thing. Now right here, between the negative 2 and the parentheses, there's nothing going on, meaning I have to multiply this. And maybe that's not obvious to some of you. Maybe it is, but you have to multiply those two. So now I have negative 4b plus 4. If you have like terms, then you should add this. But these are not like terms. So this is as far as I can go. So this is the answer for that. Okay. Now let's go ahead and go to number 7 right here. Now number 7, same idea. I'm going to plug in a 5. Let me put g of 5 here. It's equal to 5 cubed minus 5. Okay. Now, when you cube the 5, you get 125 minus 5. So this is going to be 120. So g of 5 is equal to 120. And don't forget, what that really means is that on this graph, there is a point on this graph that it's the x value is 5, and the y value is 120. All right, so don't forget about those connections. Again, that literally means what is the y coordinate at x is equal to 5. Okay, let's move on to number 9, the one that has this strange number in here. So we're going to have g of 7c. I'm going to replace every x with a 7c. Okay, now this parentheses on this one is not necessary, but on this one, remember, I have to cube both the 7 and the letter c. Okay, and I'm just going to drop the parentheses here from that one. So 7 cubed, if you use your calculator, and that you could use a calculator if you wanted to, would be 343 c cubed minus 7c. If you have like terms, then you should add them. Now remember, c cubed and c are actually different, all right? So you cannot add them. You must leave it as it is. This is the final answer for this question, okay?